Hello and welcome to today's chemistry class for SS1. Our topic today will be elements, but we are going to be taking the part 5 of that topic. And so, before we go on, let me tickle your fancy a bit. Do you know why you should not drink water while reading chemistry books? It's because in chemistry, concentration reduces on addition of water. Hope you get it. Lesson objectives. At the end of the lesson, the students should be able to define a molecule, state and explain Dalton's atomic theory, state and explain the modifications of Dalton's atomic theory. So let's get started. What is a molecule? A molecule is the smallest particle of a substance that can normally exist alone and still retain the chemical properties of that substance, be it an element or a compound. A molecule is also the smallest particle in a chemical element or compound that has the chemical properties of that element or compound. Molecules are made up of atoms that are held together by chemical bonds. These bonds form as a result of the sharing or exchange of electrons among atoms. The number of atoms in each molecule is called the atomicity of the element. Most gaseous elements like oxygen and fluorine are diatomic, that is, they consist of 2 atoms. Others, like phosphorus and sulfur, exist as polyatomic molecules, that is, they have 3 or more molecules. Helium is a monatomic molecule, that is, it comes with only 1 atom per molecule. The number of atoms in the molecule of a compound may be small or large. For example, hydrogen chloride molecule consists of only 2 atoms, while a starch molecule contains thousands of atoms. Diatomic hydrogen is written as H2 to show that it contains 2 atoms of hydrogen per molecule. A molecule of a compound contains whole numbers of atoms of the component element, that is, no fractions. Here, you can see examples of elements, the formula of the molecule, and then its atomicity. Neon has atomicity of 1, argon has atomicity of 1, hydrogen has atomicity of 2 because it comes as H2. Nitrogen also comes with atomicity of 2 because it comes as N2. Oxygen that comes as O2 has atomicity of 2, while ozone that comes as O3 has atomicity of 3. Phosphorus has atomicity of 4, while sulfur has atomicity of 8. Now let's go on and take a look at Dalton's atomic theory. In 1808, John Dalton proposed the atomic theory, which can be summarized below. 1. All elements are made up of small indivisible particles called atoms. 2. All chemical changes result in the combination or separation of atoms. When atoms combine with other atoms, they do so in simple ratios. Atoms can neither be created nor destroyed. Atoms of the same element are alike in every aspect and differ from atoms of other elements. These are the 5 theories that John Dalton proposed. But as we see along the line, some of these theories have been proven to be wrong. So, let's take a look at the modifications of Dalton's atomic theory. The statement where John Dalton said all elements are made up of small indivisible particles called atoms has been proven to be wrong. This was done by Sir Ernest Rutherford when he told us that the atom is built up of 3 main types of subparticles: the proton, the neutron, and the electron. It is not an indivisible solid piece. It is actually divisible with these 3 different subparticles. John Dalton also said that atoms can neither be created nor destroyed. This statement only holds good for ordinary chemical reactions. However, during nuclear fission and fusion, the nucleus can be destroyed with the release of a tremendous amount of energy, and new nucleus or new atoms are created during this process. Another proposition of the theory said that atoms of the same element are alike in every aspect and differ from atoms of all other elements. This also has been proven to be wrong. The discovery of isotopes makes this statement unacceptable. Chlorine, for example, has 2 different atoms or isotopes which differ in their neutron content and hence in their relative atomic mass. They have same atomic number but different chemical activities. John Dalton also proposed that when atoms combine with other atoms, they do so in simple ratios. This statement is true for only inorganic compounds, which usually contains a few atoms per molecule. Carbon, however, forms very large organic molecules, such as proteins, fats, and starch, which contain thousands of atoms per molecule. Summary. In this lesson, we studied molecules, atomicity of molecules, Dalton's atomic theory, and then the modifications of Dalton's atomic theory. So, let's now take an assessment to see how much we studied in this class. Question 1. A molecule is the smallest particle of A matter that can exist in free state, B, an element that can exist in a free state, C, a radical that can exist in a free state, D. A lattice that can exist in a free state. Question 2. The number of atoms in a molecule of an element is called A. Proton number, B. Atomic number, C. Atomicity, D. Basicity. Question 3. Which of the following was not stated by John Dalton in his atomic theory? A. All matter are made of divisible particles. B. Atoms can neither be created nor destroyed. C. When atoms combine with other atoms, they do so in simple ratios. D. All chemical changes result from the combination or separation of atoms. With this, we have come to the end of this class. Thanks for watching and see you in the next class.